Have you ever paused to wonder why water makes a unique burbling sound when it's poured? It's a sound so common, yet so unique, that it becomes a background score in our lives. From the gentle trickling of a stream to the powerful rush of a waterfall, the sounds of water are as varied as they are intriguing. But what is the science behind these sounds, specifically the burbling sound of water being poured? Is it simply the water's way of conversing with us, or is there a more complex explanation hidden beneath the surface? Today, we're going to unravel that mystery, diving headfirst into the scientific explanation behind this curious phenomenon. We'll explore the physics of fluids, the role of air and pressure, and even how our own perceptions come into play. Intrigued yet? Well, prepare to dive into the depths of this fascinating subject. Before we plunge into the specifics, it's crucial we understand what sound is. Now, sound isn't just something we hear, it's a fascinating scientific phenomenon that begins with something as simple as a vibration. Imagine a pebble being dropped into a still pond. The pebble disturbs the tranquil water, creating ripples that spread outwards from the point of impact. This is quite like how sound works. When an object vibrates, it creates a disturbance in the surrounding medium, whether that's air, water, or a solid object. And just as the ripples spread outwards on the water's surface, so too does this disturbance propagate through the medium. This disturbance travels in waves, and these aren't ordinary waves, but acoustic waves. Now you might be wondering, what makes an acoustic wave special? Well, these waves are compressional or longitudinal waves, meaning they move in the same direction as the disturbance. To put it simply, they alternate between compressions or squishing together and rarefactions or pulling apart. As these waves travel, they carry the energy of the original vibration with them. This energy is what we perceive as sound when it reaches our ears. Our ears are finely tuned instruments that can pick up these subtle changes in pressure and convert them into electrical signals. These signals are then sent to our brain, which interprets them as sound. From the soft hum of your refrigerator to the loud roar of an airplane overhead, every sound you hear is a result of this intricate dance of energy transfer. It's a testament to the incredible complexity and adaptability of our hearing system and the fascinating physics of sound. So, sound is essentially a disturbance that travels through a medium, like water, air, or even a solid object. It's a journey of energy, from the source of the sound to your attentive ears, brought to life by the simple act of vibration. Sound, as we experience it, is truly a marvel of nature and science combined. Now that we understand what sound is, let's examine the physics of pouring water. We've all heard the familiar sound of water being poured, a sound that can range from a gentle trickle to a powerful gush. But have you ever stopped to wonder why it makes the sound it does? Well, let's dive into the science of it. When you pour water, the speed and volume of the water being poured play a significant role in the pitch and volume of the sound produced. A gentle pour, with less water coming out of the vessel, leads to a softer sound, while a faster pour with more water results in a louder, more intense sound. This is because the faster the water is poured, the more air pockets are created by the water colliding with the surface, which produces sound waves. The pitch of the sound is also affected by the speed of the pour. When you pour water quickly, the pitch is higher due to the increased frequency of the sound waves caused by the rapid creation and popping of air pockets. A slower pour, on the other hand, results in a lower pitch, as the frequency of the sound waves decreases with the slower creation of these air pockets. But that's not all. The shape and material of the container into which the water is being poured can also influence the sound. A wide, shallow container will produce a different sound compared to a narrow, deep one. This is due to the way the water spreads out or is funneled when it hits the surface. The material of the container also plays a role. Metal containers, for instance, can amplify the sound due to their resonant properties, while plastic or glass containers may absorb some of the sound, making it softer. It's fascinating, isn't it? The seemingly simple act of pouring water is actually a complex interplay of physics, involving speed, volume, air, and materials. So, the sound you hear when you pour water is influenced by a number of factors. Now, on to the main event, the science behind that distinctive burbling sound. Our story begins with something called fluid dynamics. It's a branch of physics that studies how liquids and gases move. When you pour water, the flow isn't smooth and continuous. Instead, it's characterized by a series of disruptions. These disruptions are what cause the formation of bubbles. As you pour, the water hits the surface and creates turbulence, which are random, chaotic fluctuations in the fluid. This turbulence traps pockets of air, forming bubbles. These bubbles are not stable, and they collapse very quickly under the pressure of the surrounding water. It's the formation and collapse of these bubbles that creates the sound we're familiar with. But what makes it a burbling sound? Well, that's where the speed comes in. If you pour water slowly, you'll get fewer bubbles, leading to a quieter sound. Pour faster, and you'll trap more air, causing more bubbles and a louder burbling sound. And what about the pitch? The size of the bubbles determines that. Smaller bubbles, with their higher surface tension, resonate at a higher frequency and produce a higher pitch. Larger bubbles, on the other hand, have lower surface tension and resonate at a lower frequency, creating a lower pitch. In essence, the burbling sound of pouring water is a symphony conducted by the laws of physics. Each bubble is like a drum, and the frequency and volume of their beats are controlled by the speed and manner of your pour. So next time you pour a glass of water, remember, you're not just quenching your thirst, you're also creating a symphony of sound, a testament to the intricate and fascinating world of fluid dynamics and acoustics. So, the burbling sound is the result of bubbles being formed and collapsing in quick succession. It's a simple act, but with a complex and beautiful science behind it. But there's more to the story. Our perception plays a big role too. You see, the way we perceive the sound of water being poured is not just about the physical properties of sound, it's also about how our brains interpret those sounds. And that interpretation is influenced by a number of factors. One of these is distance. Imagine you're standing next to a fountain. The sound of the water is loud, clear, and immediate. Now imagine you're standing 100 feet away. The sound is softer, more muffled. That's because as sound travels, it loses energy and becomes less intense. Our brains understand this and interpret the softer sound as coming from a distant source. The acoustics of the environment also play a part. Picture yourself in a large, echoing cathedral. The sound of a single drop of water falling into a pool would reverberate, creating a series of echoes that our brains would interpret as a single, prolonged sound. Now, imagine the same drop falling into the same pool, but in a small carpeted room. The sound would be much shorter, much sharper, because the acoustics of the room absorb the sound waves instead of reflecting them. And let's not forget personal experiences. Each of us has a unique collection of memories associated with the sound of water. For some, the sound of water being poured might bring back memories of a peaceful morning coffee. For others, it might evoke the thrill of a waterfall seen on a vacation long ago. These memories shape the way we interpret the sound of water, adding layers of emotion and meaning that go far beyond the simple mechanics of sound waves traveling through air. In the end, the sound of water being poured is not just a physical phenomenon, it's a symphony, composed by the laws of physics and conducted by our own brains, each performance unique to the listener. So, our brains have a significant role in how we perceive the sound of water being poured. So there you have it, the science behind something as simple as the sound of water being poured. We've traversed the realm of sound, understanding it as a mechanical wave that travels through a medium, be it air, water, or even metal. We've dived deep into the physics of pouring water, where the rush of liquid forces air out, creating vibrations that our ears perceive as sound. We've explored the enigmatic burbling sound, a melodious symphony resulting from bubbles forming and collapsing rapidly in the stream of water. And of course, we've contemplated the role of human perception, how our brains interpret these vibrations and give meaning to them. This journey unfurls the science hidden in the everyday, transforming the mundane into the magical. Next time you pour a glass of water, remember the fascinating science behind that familiar sound.